Optical isomer. Optical isomer is very important. Optical isomer is optical isomer. Anything which can say something is to know before the optical isomer. Before reading about the what is the optical isomer, we have to know something before knowing the optical isomer, such as about the optical activity. What is optical activity? We have to know before just what is optical activity, something know what is ordinary light. Any light which is we see as a, this is that is ordinary light. Whatever light we are seeing in home, the light which come from the bulb, that is called ordinary light. And ordinary light consists of ray of varying wavelength. As a ordinary light which come from the bulb, anything in your home have a varying wavelength, means so many wavelengths is there. So its vibration oscillating in all the possible direction perpendicular to the path of propagation. As the light in your home is glowing, then it is spread in all the directions. Light, it doesn't come in the straight way, it's spreading in all the direction from which the lights are traveling. So ordinary light consists of ray of varying wavelengths. That's why it's vibrating in all the possible directions perpendicular to the path of propagation. When ordinary light passes through the nickel prism, such as I am showing in the diagram, that ordinary light propagate in all the directions. This direction, this direction, this direction, this direction. This in all directions. Ordinary light vibrating, oscillating. But when this ordinary light pass through a nickel prism, when they pass through this nickel prism, and when they come out, they vibration in the all the directions. Their oscillation in all the directions cancels. Only one direction they will vibrate. Single plane means they are vibrating in all the planes x, y, z, x, y, and z. X, y, z, they are vibrating on the plane all the directions. So they are vibrating only on the plane. This way they are vibrating. This way they are vibrating, means only one plane they are vibrating. Only in the y plane, x plane, z plane, any plane, means only one plane they are vibrating. This plane I am showing. So this is called the ordinary light wave vibrate in all the possible direction, all the possible directions. But in the passing through nickel planes, plane polarized, this ordinary light converted to plane polarized light wave vibrate in the one directions. Only one directions wave vibrates. So this is called the plane polarized light. The device, when the device this is the device which bring the polarization in the ordinary light is called polarizer. Polarizations means vibrating on the directions. Now passing through nickel prism, vibrating only one direction. This is called the polarizations. Polarizations means all the directions to one directions. Make the ordinary light into a plane polarized light is called polarizations. Means in ordinary lights vibrates in all the directions, but after polarization they will vibrate only on one direction. Means one direction plane will vibrate only one plane. Plane polarized vibrate in one directions, one plane. And the device that bring the polarization in ordinary light is called polarizer. We have to learn about the polarizer. So this is called polarizer. That polarization means to make the ordinary light into plane polarized. I have already told polarization means is to make ordinary light into a plane polarized. Nickel prism is a type of polarizer. This is a nickel prism. By then passing through nickel prisms, they comes as a plane polarized light. So nickel prism is a polarizer, because I have write that the device that bring the polarization in the ordinary light is called polarizer. So nickel prism act as a polarizer. So nickel prism is a type of polarizer, an optical device used to produce polarized beam of light from an unpolarized beam. It is made in such a way that eliminate one of the ray by total internet reflections, that is the ordinary ray is eliminated and only the extraordinary ray is transmitted through the beam. Actually, in this sentence I want to say that nickel prism is a one type of polarizer, so that's why it is converting unpolarized light, ordinary light, into plane polarized light. That is okay, that is fine, we understand all these things. It is made in such a way that how nickel prisms are converting plane polarized. It is actually lights consist of ordinary ray and extraordinary ray. It eliminate nickel prism eliminate this ordinary ray and only it's allowed to pass extraordinary ray, that is plane polarized. That's why we are getting plane polarized. How they are eliminating ordinary ray? By total internal reflection. It is a mechanism. By total internal reflections they eliminate ordinary ray and extraordinary ray only pass. They converting. Now we understand the total internal reflections, that by this total internal reflections ordinary ray are eliminated and only extraordinary ray will pass transmitted, and we are getting plane polarized right. Then we are understanding the little bit we are learning here the what is total internal reflection. Then after we will learn detail in what total internal reflection. Actually the light are passing through maybe say nickel prisms, and they pass through this. There is a medium changer here, the medium changer, this is a other medium, this is other medium. When they pass through this medium, then ordinary ray are eliminating and only extraordinary ray are passing. Here the ray are coming or ordinary ray are eliminating, only extraordinary ray are passing. So in this way, this is total internal reflections, we are getting only extraordinary ray. Now we will learn more about the total internal reflections. Now some compound here some compounds have ability to rotate the plane polarized either to the right clockwise directions or to the left anti-clockwise direction. When the plane polarized pass through the nickel prisms, and these compounds are said to be optically active compounds, and properties termed as optical activity. Now I'll explain more about this sentence. Means they are passing through, we are getting plane polarized. From unpolarized light, ordinary light, we are getting plane polarized. So these compounds we are getting plane polarized, and some compounds in nickel prism some compounds is there. In nickel prisms some compound is there which used to reflect the ordinary ray and only allowed to pass extraordinary ray. But after getting plane polarized, this is a plane polarized light which will vibrate only one directions, this direction, any directions, this direction, this direction, only one plane they will vibrate only in one directions. So generally we are representing these terms only in the vertical directions, where standard we are representing this. So after getting this standard vertical directions, some compounds have ability to rotate the plane polarized either to the when this plane polarized, this is the plane polarized, when pass through these compounds, they have these compounds have ability to rotate the plane polarized either to the right or either to the left. Either to the right, this is rotating to the right, or to the left. They have ability to rotate the compound have ability to rotate the plane polarized either to the right, either to the left. When plane polarized pass through it, when plane polarized pass through these compounds, then this compounds is known as optically active compounds, and properties known as optical activity. Also we will learn more detail about Dextrorotatory compound. When the optically active compounds rotate the plane polarized to the right, when this optically active compound, this is called optically active compounds, when this optically active compounds rotate the plane polarized to the right, then this is called the Dextrorotatory compounds. When this compounds rotate the plane polarized to the left direction in the anti-clockwise direction, then this is called the Levorotatory compounds. This is the I have written. When optically active compounds rotate the plane polarized to the right, that is in a clockwise directions, then this compound is called Dextrorotatory compound, indicated as a D or plus. And D, the compounds may be represented like this. D या plus, anything which can be represented to rotate the plane polarized in the right in clockwise directions, and when the optically compounds rotate the plane polarized to the left in anti-clockwise direction, then these compounds, which called levorotatory compounds, are indicated by L minus. So now we will explain detail bits about total internal reflections. When the ray pass through the denser medium, this is a denser medium. When this pass through the denser medium to the rarer medium, is denser water has a more refractive index. The refractive index is denoted by this notation, refractive index. Water has a higher refractive index than the air, where when this pass through the, this is the incident angle, this is a reflection angle. When this pass through this rarer medium, then they are reflected to the this perpendicular line, there goes through in this direction. When there is a such angle, this is an incident angle, any angle, maybe any angle. When there is a critical angle means some angles, when they will incident through the denser medium and pass through the rare medium, then they are not going in the air, not going to air medium, they will get a refraction 90 degree. Here we are getting 90 degree angle. This is the R is the less than 90 degree, but here is the 90 degree. When there is a 90 degree refraction, when there is a incident angle is a critical angle, when we will the critical angle, this is called the critical angle. Critical angle, we have to there is a formula to find the critical angle. What is the critical angle? What is the angle if you will incident, then the reflection will be 90 degree. But if the incident will be more than critical angle, if the incident will be more than a critical angle, then they will totally reflected to the incident medium. Their incident medium is water, and then we are getting incident medium in the water. If the incident angle is more than critical angle, if incident angle is less than critical angle, then there are some amount of refraction, some amount of very less amount of refraction, more amount of reflection, very less amount of reflection. Refraction means pass, reflection means return. So very less amount of reflection and more amount of refraction. Here is the greater than the incident angle. If incident ray is more, has a more than critical angle, incident angle is more than critical angle, then they are totally reflected. This is the totally reflected. Totally reflected. So I have written critical angle is the angle of incident in the optically denser medium for which the angle of reflection is less. Dense medium is 90 degree. When angle of refraction is 90 degree, when angle of reflection is 90 degree, then that angle of incident is called critical angle. Critical angle has a formula to find, but we are not much focused about in the detail, because in the physics you will learn about much more detail in the total internal reflection. There is a one chapters where we will going to learn about lots of things about the total internal reflections. So here is the little bit requirement I am telling. If anyone want more detail, then I will also give you much more detail in further topics, but here in this that much is required, so I make you understand only this much of things. The aperture which measures the extent of rotation of a polarized light is termed as polarizer. Means dextrorotatory compounds, here dextrorotatory compounds rotate the plane polarized to the right, but levorotatory compounds rotate the plane polarized to the left. Here is the right rotation, left rotation. But how much rotation? How much degree of rotation? Means 1 degree, 2 degree, 3 degree, 10 degree, 50 degree. Means how much degree of rotation? The degree of rotation which measure by a device that is called polarimeter. The apparatus which measure the extent of rotation of the polarized light is termed as polarimeter. The polarimeter is a device which measures the angle of rotation of a plane polarized, that is called polarimeter. Then we will learn about the polarimeter. What is polarimeter? Polarimeter used to measure the optical rotation of a molecule in a solution. In optically active compounds, if it is dextrorotatory compound, then it will rotate the plane polarized to the right. If it is levorotatory, then it will rotate the plane polarized to the left. But how much rotated in a solution? How much rotation is observed? This will calculated by polarimeter. Polarimeter is a device which measure the rotation of a compound. So polarimeter explanation with the diagram. Here I am explaining, giving explanation with the diagram. Now the diagram is in proper size, and diagram is in a proper size. Everything is going to be view. Here ordinary light is a bulb in your house. It emitted light in the outward direction. This light is represented by this. This is a ordinary light. It's vibrating in the outward direction. But when will this pass through a polarizer? Nickel prism. Nickel prism is a polarizer. Polarizer, it is a device which make the unpolarized ordinary light into polarized light. So it will, when pass through this polarizer, nickel prism fixed, cannot be rotated. This cannot be rotated. Then a plane polarized, this is obtained. When this is a plane polarized, this is a plane polarized we are getting. This is a plane polarized light we are getting after passing through this polarizer. Plane polarized we are getting. When this plane polarized pass through a tube, polarimeter tube, this tube we are representing. This is a tube. When this pass through a tube, this is a 10 centimeter long, 10 centimeter 1 decimeter. This can be called as 1 decimeter, 10 centimeter over 1 decimeter, 1 into 10 to the power minus 1 decimeter over 1 centimeter, over 1 centimeter. So this type of conversion we have to know, because in the numerical type questions they may try to confuse by giving this type of things. So you have to notice about the generally in questions, most of the questions which were asked in the JEE Main Advanced State Level examinations anywhere, they generally put decimeter, but some place we will also possibly that 10 centimeter long distance will be given, other distance will be given, but generally decimeter. So we have to know the conversion. Once the 10 centimeter equal to 1 decimeter, so this thing we need to be remember. Yeah, you can getting the 1 into 10 to the power minus 1 decimeter equal to 1 centimeter. So this is the other things. Now when this plane polarized pass through this polarimeter tube, which is 10 centimeter long, then there is a rotation. यहाँ पे already I have written the polarimeter tube contain a optically active substance such as amino acid in solution which cause the plane polarized to rotate. This will rotate the plane polarized. How much rotation? How much rotated? This will be analyzed by this polarimeter. This is called analyzer, a rotable polarizer. This lens is rotated until the no light goes through the second lens. The angle is then measured to determine the optical rotation of amino acid solution. When this light will pass, there we are seeing that this is a plane polarized. This is entering in this plane polarized, but there is a rotation, something rotation we are getting after existing this polarimeter. We are getting this type of rotation. Then how much rotated? This is the analyzer. This will rotate, and this will, when this start passing through this, this will start rotating. This will rotate. This will till the rotate until this rotate. Whenever there is no any passing of light, when there is a stop passing means all the light will pass. This will start stop rotating. When the light will pass, this will stop rotating, and then we measure the how much it is rotated when there is a passing of light. Then this will the angle of rotation we are getting. Then we are this angle of rotation getting not this is called the angle of rotation. This is we are getting by this. This is called the optical rotation of a compound. This is called optical rotation of a molecule in the solution. So optical rotation we are getting from this analyzer, and this is called polarimeter tube. And so in this way polarimeter we are understanding what is polarimeter. We have learned lots of things. Now we learn polarimeter explanation with the diagram. This is very difficult to draw in any examinations. If any examination polarimeter asks anything about polarimeter, then this will be little bit difficult, but you can also draw this type of diagrams. If ordinary light pass through nickel prisms, then the plane polarized we are getting. then organic compounds. This will pass through these organic compounds. Then there is a vibrating resistance which we are getting meso compounds. Dextrorotatory equal to levorotatory meso compounds we are getting. When optically empty compounds, this is a dextrorotatory compounds, this is a levorotatory compounds. Rotate the plane polarized to the right, and this is rotate the plane polarized to the left. Levorotatory compounds is rotate the plane polarized to the left. This is right. Dextrorotatory compounds rotate the plane polarized to the right. Rm is the resting mixture major compounds. We can also understand by this, when this ordinary light will pass through this, there is a only one wave vibration. There is vibration in all the direction, one wave vibration, but after coming this there is a change in rotations. There is a change in rotation, but after this polarimeters, whenever this light will start passing, it will analyzer will rotate, start rotating. After passing this light, this analyzer will stop, and we are getting angle of rotation. This is called optical rotation of compounds. And now we will learn about the extent of angle of rotation depend on the number of factor. Nature of substance, wavelength of lights, concentration of the solution, gram per centimeter cube. Yeah, you can say gram per ml, anything we can say, gram per ml, gram per centimeter cube. Nature of solvent, length of path through which the polarized light passes, temperature at which the measurement are made. These are the factors which depends on the, these are the some factors which affect the angle of rotation of a lights, ordinary lights. So we have to measure now a specific rotation. Now we will learn about the specific rotation. We will learn how to calculate this specific rotation. Now we will learn about the examples, how the specific rotations are calculated with examples.